also realized that, oh, there it is. That's how you do it. So you want to see what we can do here now. Okay, so now you can get through the game a little bit more easily. Maybe we throw in another one of these to make it a little more difficult at the end.
To install Greenfoot, we simply need to go to greenfoot.org and click on the software, and you can easily download the installer for any one of these operating systems. I'm on Windows operating system, so I'm going to go ahead and download the installer. Now, once the installer has been downloaded, you need to go through the default settings, very quick and easy. Once Greenfoot is installed on your computer, you should have either a tutorial or a new scenario pop up. If not, go ahead and go up to Scenario, New Java Scenario, and let's go ahead and call this First Scenario. Just go ahead and get started in Greenfoot. So once you open up that new scenario, you're going to have what we call a world. And this world is where your environment and your actors are going to live, where the objects that your players that you're moving around the screen, or any simulation that you make, all of the actors that do anything are going to be entered into this world. Okay? We need to add our image in for our world. Right click on My World, which is specific to this exact background that we're using. And you are going to create
a maze game. And you will go to Backgrounds, and you will choose let's try this sand background. And then you do New MazeWorld, would create a new object, MazeWorld. And that's what your background looks like. Okay? And so we're going to need to create a new subclass of actor. That's going to be our walls in our world, in our maze world. So a subclass of actor, and we can just call it MazeBlock. And we are going to choose a background image because it's nice and block and square, and it's easy to manipulate, and it is 50 by 50. So it's very easy to utilize as you're creating your maze. So in order for our maze world to have walls that can line up easily, we're going to change the pixel size. So right now, every little tiny pixel that you move, you could put this maze block anywhere in here, okay? And it can look like this. But when we create our maze world, and we have our cell size, so we have 600 by 400 with cell size 1 by 1. So this 1 is the size of the cell, both the width and the height of the cell, 1 by 1. So if I change this to 20, I would have to divide each of these numbers by 20 in order for it to be the same size. Okay, so 30 times 20 is your 600, that's what you'd get, and 20 times 20 is the 400 that you'd get. So if I compile here, I have the same cell size, but these maze blocks, you can kind of see they line up a little bit more square. Now we are going to make ours so that they line up perfectly, and knowing that they're 50 by 50, you would need to choose to do 50 here, and let's go ahead and do about a 12 by 12 maze. So this allows you to have a fairly big maze, and you can line these up perfectly right here. And so my suggestion now is to quickly create a maze. It does not need to be super complex. We will be creating enemies and different things in there, so the ability to get through the maze is not the main objective here, to make it difficult to get through the maze or confusing. You're welcome to make it however you want, but I'm going to go ahead and create my maze right now. So now that I've created my maze, I need to make sure that it is saved properly. So if I right click and save the world, Greenfoot has made it nice and easy where all of my different maze blocks are. So you can see the location right here at 0, 11, and these certain different spots. Now the issue we have is when I put my maze runner in the game, I don't want them to be moving that fast, that quickly from one cell to another. So I actually want the cell size to go back to 1 by 1. And so we are going to do this back to 1 and this to 600 and 600. Okay, now the problem is that now these think that this is on the 11th pixel to the right, which is not what we want. We want the 11 times 50, so it would be in a way different spot. So all these will be in the upper left corner, and we need to edit them so that they're not anymore and they do what we want them to do. And there they are in the upper left corner. So what we need to do is go back to our MazeWorld, and we're going to have to, now there's a better programming way to do this in the future, but right now we just want to try to create a simple maze, and I want to get you guys going in the maze instead of trying to teach you a difficult concept right now. So I'm going to quickly speed through this, timesing by 50 to each number. Okay, so as I go through this, there are quite a few, but I'll go fast. So now the objects are shifted just a little bit up and to the left, so we're going to need to add in some walls here to make sure we finish this maze up. So I'm going to add in one here, and here. Okay, now we have our maze completed, and we need to create a player from our actor class. We're going to do a new subclass. We're going to call this guy Maze Runner. The animal I'm choosing is the mouse. We need to put our Maze Runner into the world, and if we put our Maze Runner in there, it's a little bit bigger than we would like. Okay, so how we're going to do this is we're going to get the image of the mouse that we already have and shrink that image down immediately as it's added to the world. So the way you do that is we're going to create something called a constructor method. Create our constructor method. Adding in comments will help you learn on your own and remember things, the reason we're doing things. It'll help with other people being able to read your code and readability. It's very important. Maze Runner. And so the constructor must be the name of the class. So this is a special method. It's called the constructor method. Okay, it has to be the name of the class. Okay, and so this allows you to edit things in the Maze Runner. They have an empty Maze Runner method. You can always create a constructor method, but by default it's empty with nothing in it. So now that we have our constructor set up, we need to change the size of the image. So we're going to get image. So if we look in our documentation, there's a lot of different things, but right here there's a get image option, so we can access the image that we currently have. And then within that, there are different methods that you can do within an image. Okay, so within this image, we can mirror it horizontally or vertically. If we're trying to do a little bit of animating, turning a character left or right in a Mario platformer game or something, you might want to mirror horizontally. But what we're going to do is scale. And what we can do with scale is we can access the image's current width. So we're going to access the image one more time to get the width. Okay, and then we're going to take the width. So we're going to scale the X. We're going to scale this image down to what the current width is divided by 2, which will cut it in half. And then take the same thing, get image. So we're going to access the image so that we can scale the image. And then we're going to access the image again to get the width of the image for the X value and divided that by 2, and get the height and divide that by 2. So that allows us to access our image. And why we don't want to put this in our act method, this will happen 60 times per second when you push run. And so the act method will happen over and over again. The constructor method will happen once just before when the world is getting constructed. So before the act method is pushed, you'll notice that when you scale, and it's in our constructor method, if you go check and you add in a maze runner, it's going to be half the height and half the width. So it's going to be nice and small and perfect for us to get through the maze. Okay? The reason that works is that in our constructor method, before the act method is run, just when we're building our world, the maze runner, we've created a constructor method, will be half the height and half the width. If we put it in our act method, it would cut the height and width in half 60 times per second. So over and over and over and over and over again. So we definitely don't want that to happen. Okay, so now that we have our maze runner, let's put them in and let's save the world. And now we need to put in our code for our maze runner. Now, our code for our ship player is going to be quite similar to the code for our maze runner. What I would like to do is create a superclass that is our movers, and we're going to have different methods for them. So we're going to put the moveAround method in there so that the maze runner could get that method whenever they want. So it'll show the opportunity that we have with superclasses to make them very useful. So we're going to create a subclass of actor. That's the first thing we're going to do. We're going to call it movers. Okay, and they're not going to have a picture. This is just going to be our superclass. Now I want my maze runner to, instead of extends actor, so it's not going to be a subclass of actor, it's going to be a subclass of movers, which is also a subclass of actors. I also want my ship player, since it's also a mover, to be in the movers class. And then we're going to take this moveAround method and we are going to cut it out. And we're just going to have a moveAround method in the ship player. And then when we go into our movers class, we can create this method. And now the ship player can access the moveAround method that is in our movers once we compile there. So now ship player can access moveAround, and maze runner, all I have to do, since it extends movers and movers has the moveAround method, maze runner, just put moveAround, open close parentheses, and now even though we're in a different world, our maze runner can move. Okay. Some of the issues though that we see with this is that the mouse will flip upside down, and we don't want that. And it'll go up. I just want my mouse to face forward and just move. So I'm going to actually change the name of the moveAround to moveAndTurn. I think that is a better name for it. And it'll make it so that our ship player can still have the move and turn, and our maze runner is not going to have the moveAround or move and turn. We're going to add in a new method that'll be a different way to turn. So public void slide around. Okay, so you're going to slide around. Open curly bracket, close curly bracket. I have public means it's going to be accessible to other classes. Void means this method is not going to return anything to you. It's just going to command. There's just output. There's no return back to you. Okay, so we're going to do similar if statements. So we're going to copy and paste, not reinvent the wheel here, but we're going to change this set rotation and move to, I'm going to use control space to find what I want here. This is getting information. We're trying to set the location and slide and not turn. So this set location is what we're going to use. And that technically is a teleport from one spot to another. But we're going to teleport so short distance and so fast that, that we'll be able to use it to slide around. Okay, so get X. If I'm going right, I'm going away from the 0, 0, so plus 4. Let's make an X and a Y value for our movers here. So in X equals get X, and Y equals get Y. That way we can just use X and Y, and X plus 4 will move us to the right 4 pixels when the right key is down, and I'm just going to copy and paste this in and just change the numbers around. So I'm going to get X minus 4. I'm going up, I'm going towards the 0 of the Y, so I'm going to go minus 4 here. Oops. I go minus 4 here, and then that would leave just plus 4 right here. Okay, so this is the slide around method. So I'm going to need to put this in the maze runner, the ability to slide around. Okay, so I need a semicolon, 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 semicolon. Okay, now we can test our maze runner. Yes, they slides as we would like, and moves around. Okay, perfect. So now we're going to talk about return types, and show how we can use return types to stop us from running into walls and return whether you're hitting the wall is true or false, as well as other things. Now that we have our maze runner the correct size and moving the correct way, we're going to have our maze runner not be able to walk through walls. So we're going to actually go into our movers class, and we need to be able to check in our movers class on another object if it's hitting our maze walls. So we are going to create a new method with a Boolean return type instead of a void return type, and we're going to call this hit walls. Open curly bracket, enter, enter, close curly bracket. If we are touching the wall, so how can we ask if the mover is touching the wall? Well, if we do control space, there is an is touching with a class, and that is touching. What have we called our walls? We just call them walls. MazeBlock. MazeBlock.class. We need one more parenthesis. We will return true because this method will be true if you are touching the maze block, so you are hitting the wall. So what it needs now is a way for it to be false, and so any other time if it's not touching the maze block it should be false. So we're going to use another keyword that you can use, and this is an if-else statement. So if this is true, return true. If it's else, we are just going to return false. So our hit walls method needs to be implemented in our slide around method. So we are going to copy that method call. That's a method call. So we are going to, So we're going to copy hit walls, and we're going to put it in as a method call on set location. So if you have the right key down, you're going to be moving 4 to the right. But if our hit walls is true, if hit walls we are going to set location -4 instead of +4. So just like Newton's law, every action has an equal and opposite reaction. So when we are pushing to the right and we run into a wall, the wall needs to push to the left just as much against us, so it balances it out. Okay, so you're going to use this in each one of your right, left, up, and down, but you just want to make sure it's the opposite. So we're going to change the Y here on up and down to +4, and the Y here to -4 to the Y. 4. Now, if you have any trouble after this, you need to test your code and make sure it works. Okay, hit walls, MazeBlock. So we go in. We don't have to change anything to MazeRunner. MazeRunner is getting the slideAround method, which the slideAround method is accessing the hit walls Boolean return type method, so it's returning true or false. And now we can easily manipulate our right, left, up, and down. Okay, these methods make it much easier to read your code and understand what's going on. So now we know if we hit the walls, we're going to get pushed. Okay, so we run the code, and then you can see that you get pushed off the walls, and now we have a working maze, okay, that you can run through. Okay, now we're going to talk about variables. Within our code, we have all these numbers here that we're using, and it's nice if we try to change a lot of these hard numbers in here into variables so that we can manipulate them at any time, and it makes for a little bit better readability and people understanding what these numbers represent if they are actually variables. So we are just going to start off with a basic speed variable. So we're going to do this outside of all of these methods. Speed is just 4 once to start. So just right at the beginning, speed will be 4. And so we could replace it all in here, but we're not using the moveAndTurn method. We're using the slideAround. We can change this to speed. And don't reinvent the wheel. Copy, paste. Oh, make sure your commas don't get erased. All right. So now we have a variable that is called speed. And notice that none of this method has no numbers in it. Okay, speed is stored as 4, and so it won't change at all for us. But now we can manipulate speed and kind of do what we want with it, and that's what we want in our code is that ability to manipulate whatever we want. And so if you want to format your code and make sure everything's lined up correctly, a great thing to do is Control-Shift-I, Command-Shift-I, and that will auto format. So if I have these all over the place and spaces where I shouldn't, Command-Shift-I will relocate all that back to where it's supposed to be. So that's a good way to clean up your code. Okay, so now that we have a variable, let's try to manipulate this variable. So we're going to need to create another subclass, and it's just going to be an object. It's just going to move on its own. So it's not going to be one of the movers that we have. So we're just going to create speed boost. And we know that mice love cheese, so might as well make it a cheese pizza for us. Okay, our speed boost is right here. Let's go into our MazeRunner and actually copy this code and put it in our cheese pizza speed boost. Create one more public. How do we make a constructor? What is this going to be called? It's going to be called the class name speed boost. And we want to reset the size of this before the act method gets run. It's just going to happen one time. So we want it in our constructor. And then when we compile this, speed boost is a little more reasonable of a size. Okay, so go ahead and I'm going to put a few speed boosts in here. And then I'm going to save the world. So now our speed boost objects are in there, but we need to have our maze runner react, something happen when we collect the speed boost. Okay, so in our movers class, we have our speed as 4. We need to manipulate that. So we're going to create public void collect boost. Okay, and so now that we have our speed variable, we need to manipulate the speed variable with a method for when we collect the boost. It will increase our speed. So if we are touching the speed boost, we need to increase our speed and then remove the speed boost from the world. Okay, so our is touching once again will come into play. So if we are touching the speed boost dot class, open curly bracket, enter, enter, close curly bracket, we are going to have our speed equal speed plus 1. But actually this happens so often because that's the way you add one more to a variable that they have a shortcut speed plus plus. Okay, and then after we add to that variable, we would like to remove what we are touching. So let's see what we have here in our methods that we can grab. We have a remove touching here. Okay, removes one object of the given class. So we are going to remove speed boost and with a semicolon. And now our collect boost method is stored in our movers. Okay, but we need to use that in our maze runner. We need to make sure we go in and use the collect boost method. And then we need to check, make sure this works. So we're going to run, okay, and then are we faster? Okay. And now you can test in a few different ways. You can just drop a couple of speed boosts right here and see how fast you can get them to go. Okay, you can also inspect. Speed is now 7, so it started at 4 and now it's 7. See how fast you can go, and it's hard to control once it goes too fast. Okay, because it'll jump. All right, and so another thing we can do that we're going to need to do is have a max speed boost. So pretty simple here. We can make in the act method, we can just have a simple if statement that is max speed essentially. So we can create our own method if we'd like. Might as well. Public void max speed, and we're going to set our speed variable. So if, and we're going to use a math expression here. So speed is greater than 7. Actually, we're going to do greater than or equal to. So greater than first, then or equal to. So if speed is greater than or equal to 7, open curly bracket, close curly bracket, we're going to do set speed equal to 7. Okay, so that means the max it'll be is 7. So if it's greater than or equal to 7, it'll just stay at 7. Okay, compile. Let's make sure this works. If I add a whole bunch of speed boosts right here, should be stuck at 7. Okay, 6, let's add one more. 7, let's add one more. Max speed needs to be placed in a method in your maze runner. Okay, and actually max speed might be more specific to our maze runner, but we can just call it in right here. Okay, so now the max speed our maze runner can get is 7. I'm going to try dividing our size by 3 so I can get a little bit more room to go through the maze. Notice I've been bouncing off the walls a little more than I have in the past, so just give you an opportunity to get a little bit more flexibility moving around the maze a little bit better. Yeah, I like that better. Okay, so let's go ahead and do that. Scale it down to 1/3 of the size so you can move around a little bit better. You don't have to do that, but I feel like that's a good thing to do. Now let's move in some enemies. And now these enemies are going to move on their own. So we're going to create enemies class. And we're going to have our enemy flyer. And we are going to set the image of the enemy flyer to something that can fly, that might intimidate a mouse. Okay, we have our pelicans. Okay, now we're going to use that same code to make these pelicans a little smaller. Okay, so we're going to copy. Let's go ahead and go into our enemy flyer, public enemy flyer. Command V. Let's change these to 2. Okay. Now these pelicans will be nice and small. Then we can get going with the enemy flyers and their movement. Okay, so I'm going to have just a very simple them move forward. So there's just the move method. That's all we really need right here. And we'll just have them move 5. So we'll be moving pretty fast. Okay, and then within that, we will have our wrap at edge code. And so we're going to create a method in our enemies, because I could see us using this in multiple levels to create our wrap at edge, public void, because we are going to want to wrap our enemies to the edge of the world. And so wrap at edge, we're going to be using if statements to check if the object is at the edge of the world. Okay, so the edges of our world are get world.getX or get width, get world.get height, because we can access our get world code and we can do control space and see what it gives us. This is still our actor code, dot. Okay, now we have dot. Now notice that that's different here. Okay, so what can we do? Well, we can get width and get height. We've done that before. So we're going to get world.get width. And if our x value, int x equals get x, and int y equals get y, and we can do if x is greater than the width of the world minus 1, because remember we start at 0. we also should create a variable int world width equals get width minus 1, get world get width minus 1. Okay, creating this into a variable will make it much easier to work with. So we're going to set our location to, if we're greater than the width of the world, we want to go back to the beginning of the world. So that would be 0 on the x value, and our y would be just y. Leave our y the same. Okay, now we're going to do a combination of that, but moving some things around on each side of the world. So if x is greater than world width, well, what if x is less than or equal to 0? Okay, so if x hits 0, where do we want it to go? Well, we want it to go to world width, and we actually need a minus 1 more from world width, and we need to set world width greater than or equal to, and we need to do world width minus 1 more so that it gets to the size of our world minus 2, so it doesn't bounce back and forth between going back to 0 and then going back to the world width. So we actually need to change this to a 1 as well, so that when it relocates from the right side and tries to go to the left side, it doesn't hit the 0 part of the world and then bounce back to the right side, because that way it would go back and forth and it would get stuck. So make sure you have 1 pixel of wiggle room so that you relocate not to the 0, because then it'll flip back to the right side, but relocate to the 1 when we wrap at edge. Okay, let's try and do this again. So y, and we need to do our int height, world height equals get world dot get height minus 1, and we want our world height. So if y is greater than world height, greater than or equal to, excuse me, we want the x value to stay x, but we want the y value to go to that 1, just like we did here. And then y is less than or equal to 0. We need our x to stay the same. Our y will equal world height minus 1. Okay, and now we put wrap at edge in our enemy flyer. Get height, open close parenthesis. All right, so now we test. So if our enemy flyer's in here, we run it, whoo, they're flying. All right, it wraps at the edge. Okay, and so that's how we create our enemy flyer and have it wrap at edge. And so now we want to make it a little bit more difficult to get across our screen. Okay, and so we are going to create an enemy flyer object. Now it's saying that we have an error. I have added in an object and then I deleted it and then I saved the world. And so when you go into the MazeWorld code, the enemy flyer was created and then we added it to the world, but then we removed this object. And so that memory of the object getting removed is saved into our code. Now, unfortunately, when we deleted it and then we added 2 more in, it read this one as getting deleted, and then it added 2 more in. So either I need to get rid of the remove object and the one that's also named enemy flyer. So when I created this one and then I deleted it, the next one I created was also named enemy flyer. I can do 2 things here. I can name enemy flyer 2, but we already have that. So I can name an enemy flyer 3. Remember, we can name this whatever we really want, as long as when we add the object into the world, it is also enemy flyer 3. So this will add this object into the world. Okay, but we can simply remove the remove enemy flyer, and we could just have enemy flyer 1 and enemy flyer 2. Really, whatever you name it, like I said, is fine, as long as it knows that it's getting named. Okay, so then once we compile and go back to our code, now there's no error that's showing, and we still have these 2 enemy flyers. Now we want to go back in our code, and if we want it just for this maze runner, we could put it in maze runner, but we could also put it in movers. Okay, and so we need to create a new method. So I'm scrolling all the way down to the bottom in my movers, and I'm going to create a public Boolean hit enemy. Okay, now the reason I'm using a Boolean instead of public void is because I want all of my enemies in all of my code to be able to access this hit enemy Boolean and know if it's true or false. Okay, and so if similar to is touching the speed boost, so I need to realize, what do I actually want to do? Well, I want to know if my mover, whatever mover I have, is hitting any of my enemies. Okay, so we already did if touching. Okay, so we can do that again. If is touching, which is an actor method. So if I do control space, I could see that is touching is right here, and it asks for the class. Okay, well, I could do my maze runner if it's hitting the enemy flyer class, but I want this method to have the ability to know all of the enemies. So that's why I'm going to do enemy.class. Okay, and I need to add an extra parenthesis there. And then every time I create a new if statement, I do enter, open curly bracket, enter, enter, close curly bracket. That keeps my indentation almost perfect. If you want to fix your indents, and you notice your color scheme's off, or you have the error reached end of file while parsing, that means you have a curly bracket that is not closed off. Error found in class. Okay. If you click on the red right here, it'll tell you what your error is, and that error is reached end of file while parsing. That tells me my curly brackets are off. Now I want to move this over automatically. Let's say it was way over here and all of it was all messed up. You can always do edit auto layout. Okay, and that'll fix it up right there. Or Command Shift I will do that same thing. So the keystrokes are Command or Control Shift I, depending if you're on a Mac or PC. So if you're touching enemy.class and it's giving me an error because actually my class name is enemies, which I guess since I have more than one enemy, eventually we're going to create more than one enemy, so enemies is okay as a class, but you really want to try to, if you're having more than one instance of the enemy flyer, the singular enemy flyer, you would want to make it singular, because just because I have 2 pelicans on there, those are 2 separate objects. They're not 2 different classes. So here I have multiple enemies and multiple movers, because eventually I will have multiple enemies classes and movers classes. So if we're touching any of the enemy's class, we're in the movers, we want to return true. Okay. Another reason why you want to use a Boolean return type, here's the return type, is that we have the ability now to access if hit enemy is true or false. And then within our specific mover, we can say what we want to do now that hit enemy is true or false. So what if we wanted to do something different in different classes? So like our maze runner, if our maze runner hits an enemy, we might want it to relocate to this exact spot. But our ship player, which is in a different world, we might want it, if it hits an enemy, we might want it to do something completely different. And so you want to have that flexibility in your code, and that kind of goes on and on. The more in-depth coding and the more game development you have, and programming in general, having the flexibility to use if it's true or false and use that in different ways and have that react in different ways is very helpful and very good. Okay, so we need to have another. So if I just left it like this, there would be an error. Okay, and the error would say missing a return type. Basically, a Boolean has to either return true and have another way of returning false. So basically, otherwise, if we're not touching any of the enemy's class, we want hit enemy to return false. Okay, and now we're going to use this Boolean specifically for our maze runner right now. Later on, we'll use it for a completely different purpose, and we won't relocate it back to the same spot. But now we want to relocate this. So we're going to access inside of our method. We need to create a specific method, an action method that does something. So when we don't have a return type generally means it's a question. Is it true or false? What is the number that we're trying to get if we're using an int return type or a double? I'm going to call it maze runner hit. Okay, so we specifically know that the maze runner is getting, when the maze runner gets hit right here, and so we're going to say if the hit enemy, just general hit enemy, which we have, general hit enemy, which we have in our movers super class. So our movers has the hit enemy, and our maze runner is going to access that method that we have created. Just like our ship player can access the actor code when we do control space, or maze runner can access the actor methods and functions when we do control space. We can do the same thing by our own created methods. Okay, so our maze runner, if hit enemy, open close parentheses, equals true. Okay, we will set our location of the maze runner to 40, 560, and that will return us back to our original spot. Our original spot in our maze runner was 40, about 40, 560. Okay, and what's nice is that this is specific to the maze runner. This is not specific to the maze runner, but it's accessible by the maze runner because the maze runner extends movers where hit enemy is, or hit enemy Boolean method is. Okay, now there's a better way, an easier way to do this. We can just get rid of equals true. That would work, and that will work. But the faster and easier way to declare this is simply hit enemy. That just is saying that Boolean must be true. Okay, and if you do not want to hit the enemy, you just add an exclamation point, and we'll go over that more a little bit later. Okay, and so that would be if it's false, you'd add an exclamation point. Okay, so let's check and see if that works. We need to first call this maze runner hit into our act method for our maze runner. And now we can go in. If we get hit, we go back to the beginning. Now you have a little bit of something that you need to dodge in your maze. And you can go in, and it adds a slight bit of difficulty to your game. And we're going to continue to add some difficulty to the maze game as we go. Now we're going to create a new enemy. We already have our enemy flyer that flies across the screen and wraps that edge. This is going to be an enemy walker, and they are going to be bouncing in our maze. And so they'll react to the walls and create a different aspect of your game. And that's very important to know. Simple games are good, and our games will be simple. But you want the game to be a little bit more dynamic than just having one type of thing. And to be honest, it would be better practice to not copy and paste this, but because of time constraints, and we'll get to this a little bit later, we are going to just do the old brute force, copy and paste. Now, it would be much better practice to have a method that scales down our enemy flyers, and we could pick the amount that we want to scale it down, but that's a couple steps that would take a little bit longer as of right now. But normally you want to do things the hard way at first because it'll pay off in the long run. And so now with our enemy walker, I need to create a constructor class, so I'm going to paste. So I'm going to copy what I have here. So I'm going to paste the enemy flyer code that I copied, and I'm going to change it to enemy walker. Okay, now that was pretty simple, quick and easy, so you can see why I wanted to do that then. Okay, and now our enemy walker is going to move in a new and different way. So our enemy flyer moves in one way, very simple, very straightforward, and has rapid edge. So we can access rapid edge in our enemy's code if we need it for our walker. Okay, but we should create a different way for the walker to move. So I want this specific to the enemy walker. I don't want this method accessible to other classes. So I could just call it private void move around, and that will make it so that it's only accessible to this class. Now, the reason most of the time we do public is because as I'm going through this, there's going to be times when I'm going to be accessing different methods from different classes, but this move around method for specifically my enemy walker is just going to be for my walker. So now that we've set up our method, we need to really think about how we're creating this method and what we want this method to do. So we want an enemy walker to be able to be in here and bounce back and forth along the walls. Okay. We also want it to bounce down a class. We can first set up our X and Y like we've done before. Get X, Y equals get Y. So within this method, it'll always start off by accessing the X and Y, and we want to say that we're going to be moving by our X and our Y value. Okay, but we don't know, we need to have a separate variable that tells us if we want to move up and down or left and right. Okay, and so this method is going to require something that's telling us the direction that we want to go. Okay, and so there's multiple ways you can do this, but we are going to create a parameter that will be given to us that will tell us whether we're up and down or left and right. So we're going to put a variable inside of our constructor, which is right here. Whenever you see public and the name of the class, the enemy walker class, it is the constructor, and that's where we put our physical traits and characteristics of our specific objects that we want to use. So we have one object that has something specific in the parameter and another object have something entirely different in their parameter. but we need to define what we want. Okay, so we're going to create a Boolean that says up and down. So this will tell you if it's true, we're going to go up and down. If it's false, we're going to go left and right. So now that we've created that parameter, we need to set that equal to something that is available within the class. So it gets given up and down, but enemy walker class needs a way to receive that information. And so if we do Boolean up, if we create a Boolean up down, we can have up down and set it equal to up and down. Now that we have our variable up down and it's equal to the field that is coming in, this parameter field that's coming in that is up and down, and we're setting up down equal to up and down, we can say if up down is true. Oh, my indentation got off. Control Shift I, make sure that your color scheme is right. Okay, good, my class is covered. Okay, your Y value is going to add speed, but we need to create a variable for speed. So int speed equals 2. It's a small amount right now. Okay, else if up down is not true, so I use the exclamation point, I want to set my location to x plus speed, comma, y. Now, we want to put our moveAround method in here. And as you can see, our enemy walker that we've added in already is having a problem. It says constructor enemy walker in class enemy walker cannot be applied to the given types. It requires a Boolean. What it has found is no arguments or an empty parameter. So the actual and the formal argument lists differ in length. So what it's saying is it needs the Boolean that we just said. Well, is up down true or false? So we need to decide, is this going to be an object that we move up and down? Well, let's look in our code. If you remember, this was right on the corner, so it really could be true or false. Okay. Now we compile, no syntax errors, and we should be able to be good to go. So now our enemy will add to the speed, add to the Y value, and so it should move down. And it does. Okay, so let's add one more in, and you'll see something interesting when we try to add another one in. It adds a parameter that we need. I want this to be false. So now this guy is right on top of the other one. Now this one will move to the right, and this one will move down. So you can see now how we can specify our objects of the same class have in our movers hit walls. So this method could actually so I've already created a hit walls method, so I shouldn't reinvent the wheel. So I should just be able to do if, but I won't be able to, and you'll see why. If hit walls, let's get this lined up right. So here is my field, an empty parameter, and then I need to close the parenthesis after it. Open, close. Now there's an error. Okay, and the error pops up because we don't have access to the hit walls. If you remember, our hit walls is in our movers class. Our enemy walker is all the way over here. Okay, so I'm going to create a separate class that is movers, and the movers will be both the enemies and the players that are moving. So I'm going to create a new players class that'll go under movers, and it'll be a subclass of movers, a superclass of maze runner, a superclass of ship player. So it's going to go right in between these two in the hierarchy. And then I'm going to move enemies along with me. Okay, so maze runner is going to have maze runner. Instead of extending movers, I'm going to have it extend players. Okay, still an error there. We're not there yet. Ship player. And look, maze runner has moved under players. Players can access movers. Movers can access actors. So you see the hierarchy going here. Now, ship player going to do the same thing. Still, we'll be able to access all the code. Move and turn, which is in our movers, can access all the code from movers because it's still a subclass of it. Now, I want my enemies to also extend players. And so all the players, not players, so I want my enemies to be able to be a subclass of all the movers, because an enemy can move, and so can the players, but they're on two different sides. The players we're going to control and move around on our own, and the enemies move around all by themselves, and the enemies move all by themselves. Okay, so we go into enemies, and we're going to change extends actor to extend movers. And now, if we compile, we go back in here, we have our mover superclass, that's all up here, and we have enemies, and we have two enemies in there, and we have our players, and we have the maze runner player in this world, and our ship player in another world. Okay, so now we want to go back, and we are trying to have our enemy walker be able to hit walls, and now they can, because our enemy walker goes into enemies, and then the superclass of that is movers. And what do you know inside of movers is that hit walls method. Okay, so instead of having to copy and paste and move it around and figure out where I'm going, now I'm going to say if hit walls, shoot, we already have a way to hit walls, but we might do something a little different than our maze runner. So if our maze runner hits a wall, it's going to relocate. We don't want, oh, hits an enemy. But if our maze runner hits a wall, and if we have slideAround method, if our maze runner hits wall, this happens. But we're going to use a different method for our enemy walker. If enemy walker hits wall, we're going to do our own thing. So let's create our own method, always a good idea. And this we might use for other enemies, so we might as well make it public. We can change it later. And we want to make sure that this method is lowercase, so you know the difference between a constructor class that you're throwing in there or a class that you're referring to would be capitalized, and a method and variables are lowercase. So you always want to keep with that practice. So enemy hit walls. So now that we have our enemy hit walls set up, Control Shift I. Okay. Enemy hit walls. So now I'm going to use this code that I started here. I'm going to move it down to hit enemy walls. So if the enemy hits the wall, what do we want to have happen? Well, we want the speed to, so the speed moves it up and down. Well, right now it just moves it down because it's plussing the speed. Okay, and if it's not up and down, it's just moving to the right. But we want, if it hits the wall, it to move the opposite direction. So speed equals negative speed when you hit a wall. Okay, so if I add in an enemy walker that is moving to the right, so if I have it be false, up, down be false, This enemy walker will move to the right. This one will move down, but it won't hit a wall, so we won't be able to test that one, so we need to test this one. Okay, so if it hits a wall, we need to put it in our act method. Okay, so hit enemy walls needs to make sure you put it in the act method. We're going to add in one more walker here, false, so it can go right and left. So this one will go right and hit a wall. This one will move down and won't hit a wall, so we wouldn't be able to test that. So boom, it hits a wall, it bounces off. Excellent, that's exactly what we want. Okay, now we want to go in our walker and say if we hit the edge. Okay, and let's check and see if we have a command, a method for that. Okay, well, if our actor is at edge, okay, so we can use that, and we can use that. And so what do we want to have happen if they're at the edge? Well, I want to see them bounce off the same way they bounce if they're in the maze. Okay, so we can do is at edge, a method already stored, and we're going to learn what we call a logical operator, and there's more than just one of these. So you want it to, if it hits the wall or it hits the edge of the world, and we already know there's the is at edge method. So if you do shift and between the enter and the backspace, or delete and enter on a Mac, there is, if you hold shift down, there is the backslash, but if you hold shift down, it creates these lines, and those pipes, we call them, is the or. So if it hits the walls or is at edge is true, we will bounce. So now we have our enemy walker. We might throw in another enemy walker false that bounces left and right. We can put this somewhere in the code so we can see it bounce off a wall and left and right, and we run it. And now it bounces at the bottom, it bounces at the left, goes up and down, hits the wall, so it interacts exactly how we want it to. And now our game's a little bit more dynamic, and we can figure out some of the best spots to put these in. So when I'm running through here, okay, is this possible? We need to know the difficulty level in our game, and it looks like it's near impossible. So also realize that, oh, there it is. That's how you do it. So you want to see what we can do here now. Okay, so now you can get through the game a little bit more easily. Maybe we throw in another one of these, make it a little more difficult at the end. So you can always change the name of your classes by just going into the editor and just changing the name in the code. And then that will, Greenfoot will automatically change the name here. So I'm actually going to change it one more time to UN screen, so there's no confusion on what's going on. And then I'm going to say, and these aren't movers, so they can have their own class for now, and if I need to make a super class later, because I'm seeing the same thing getting used, then I'll do that. But I'm going to create the UN platform, and we can have create a door. And that can be our UN out. That image, my MazeWorld. So I'm going to go in and I'm going to delete where it gets relocated back to a location that is a little bit lower than I wanted originally. Okay, so we're going to go back in and not change the location. Okay, that's closer to where I want it to be. Okay, so sometimes you got to fudge numbers around inside the code. You can't just delete this and add in another object and keep deleting and adding. So if the maze runner hits a UN platform, actually if any player hits a UN platform, we want the UN screen to pop up. So our players, we can do public because we want to be able to access this later. UN method. So if we win, we want a lowercase y here. So set up our method. Enter, enter. some space, Control Shift I. If any player is touching a UWin platform, dot class. Okay, does that work? Yep. No errors. So if you're touching the UWin platform dot class, we want to add an object. So we need to do get world, because inside of our world code, that's where add object method is available. Just like how in our actor class there's move and turn and set location, our world class has add object. So we need to go add object. So we need to access the world class. So go back into players. We're going to do get world. So we're going to use the get world method, which accesses the world class. And a dot is kind of the travel, a signal for traveling, referencing somewhere else. So we're going to reference the world class, and we're going to steal their add object method that they have. And the add object method will create a new object of whatever class you put in here. So we want the UWin screen. Oh, no, we don't want to add a whole class in there. We want to add one add object. So we've actually already done this before. So in our MazeWorld, it does it for us. We add object and the name of the object. So what is this enemy walker 3 literally? What object is it? Well, it's a new enemy walker. Now in this case, it's got a specific parameter. But when we add object UWin platform, we are just creating a new UWin platform, but we're naming it lowercase UWin platform. Okay, so we can create, since we know we're just going to create one standard UWin screen object that doesn't move or doesn't have anything specific in the parameter, we don't need to name this variable. Now, sometimes people would do what they did in the MazeWorld when you get a little bit more complex into programming and further along in this course, we might create a method here, or excuse me, create a variable here that represents UWin platform, open close parentheses, so the new UWin platform object. But right now, we're just going to say new UWin screen, and the location needs to be the center of the world. So we're going to get world again, dot get width, because this is the x value, and divide the width by 2. Get world dot get height divided by 2. Okay, so now our UWin needs to be available for whatever player that is currently in the world. Well, the player that's currently in the world that we want to use it with is our maze runner. So our maze runner can access the players class, which is where our UWin method is. And so our maze runner can win now. Okay, so I could go through it and challenge myself again. You're welcome to do it, but I want to save time and cheat my way to the end. You win. Hold on, there's an issue. If you notice, all my objects are slowing down, but they're still moving. That's not how a game stops. That's not how you beat a game. And on top of that, notice what's happening. Let's check it out. So, oh, why is it slowing down? That's weird. And watch what I do here. If I move this up and out of the way, you know what's underneath here? You can see it. Another UWin. And another UWin. And another UWin. And another UWin. And another UWin. So there's a couple ways you can do it. We need to go into the UWin. We need to change something in that code. So go into players, or UN if you're touching the platform. And now there's a couple different things you can do. You could say, you could create a variable and have it, if we wanted to create a number, an int, you could have it be 0, or you could create a Boolean variable and have it be game going. And if game going is true and you're touching the platform, you could add an object UN and then change game going to false because game's not going anymore. And then that would make it only happen one time. But Greenfoot actually has a method that they've created that we can use. And so it's not in your world, not specific to your world or specific to an actor. It's specific to Greenfoot, similar to like pushing a key down and having input. This is specific to all of Greenfoot. So it's in the Greenfoot class. So Greenfoot dot stop. So Greenfoot dot stop, open close parentheses, is a method that will stop Greenfoot at that time. Now we check. If you hit the UN platform, UN pops up, and look, my run button is still available to be, now it's available again. So let's look at this again. So I push run, and I go and I hit the UN screen. All my objects stop. I have one UN pop up, but if I push run again, a new UN will pop up, but it stops it again. So it literally just stops it from running. Okay, now the last thing we need to do is we need to add a way to lose the game because I don't want unlimited tries. You have a certain amount of lives. So now we want to create a parameter for our maze runner so he only has a certain number of lives. So our maze runner needs to have a parameter in its constructor that is number of lives. Okay, so we can have int maze runner lives. Okay, so we've made it available for this class to have a variable maze runner lives, but it doesn't know what we want it to set it to. Well, we want to set it to whatever, similar to what we just did, actually exactly like what we just did. We want it to be equal to whatever gets plugged in the parameter for lives. Then we can manipulate lives like we did before. Okay, so we can do public void lose life. Okay, and now all we need to do is if hit enemy lives, which is what we've plugged in. But wait, it doesn't recognize lives. Because the only thing that it recognizes are variables that have been created within this class. So we actually need to do maze runner lives, which is equal to what we've plugged in. So essentially it's the same thing, but the computer doesn't know what lives is as is. So we need to change this to maze runner lives. And we are going to do minus minus. Minus minus subtracts maze runner lives from its previous down one. Okay, and then our other maze runner hit program method allows it to relocate. Now, let's say I wanted to have a specialty where I have unlimited lives, or I wanted a different way to gain back lives. It's still important that we created this parameter and we created this variable, but we really probably could have just put maze runner lives in here. But it's not much difference in amount of time, and this gets it broken down a little bit more. Okay. So now we have an issue with our maze runner because we don't know how many lives we want to give it. Well, in this game, let's give it 3 lives. We have not called that into the act method yet. So now we need to call lose life into the act method. Now we need to copy and paste lose life into the act method. Copy, paste. Okay. Then now when we go in here, go back into my code. Then I go back into my game. And 1, 2, 3 lives down. Then I check. inspect. So before, when I created my own method of lose life, I thought I was breaking down the problem a little bit more and making it work a little bit better. But if you realize our hit enemy, our maze runner hit happens prior to the lose life. So we're resetting the location and then it's checking again later on if hit enemy is true, but when it's relocated, hit enemy is false. So it never was getting rid of my maze runner lives. So there's a couple solutions. I could cut and paste it in here, but I still want it separate. So if I make lose life higher up in my act method and make it above maze runner hit, then when I run it and I hit an enemy, 2, 3, and I inspect and check what my maze runner lives are, now it's 0. Okay, so now we can use that. So we can create a public void uLose method. If, Control-Shift-I, okay, if our maze runner lives equals 0, we are going to do the same get world dot add object new uLose. So we're going to create a class uLose and we are going to add it in similar to how we did with the UN. So get world get width divided by 2, get world dot get height divided by 2. Now I've already written this code twice now in the same game, and I have a feeling I'm going to continue writing it. So in a future lesson, I'm going to show you how you can create this in a way that we can manipulate this and do this automatically, because this has taken a little too much time for my liking. So then I'll do Greenfoot dot stop again, because if you lose, you want the game to stop. So the new uLose needs to be created, so there's going to be an error there because the uLose has not been created. So just like the UN platform, instead we don't need a platform for the uLose, we just need a uLose, and I need to capitalize this. I didn't capitalize it before, so I need to go back into Maze Runner, and I need to capitalize the Y in U and uLose. And then again, we're going to create we're going to set this image. Do need to make sure that the uLose is in the act method, as always, something that can be easily forgotten in Greenfoot. You need to make sure you put it in your main act method so that it actually, this is where the action happens, so it actually runs. So now, if I hit 1, 2, 3, game over, game stops, and we have created our first game, our first full game in Greenfoot, and this is our maze game. I hope you enjoyed it.